This conference will now be recorded.
Well, good morning, good afternoon, or good evening, depending where you are in the world. Welcome to the quarterly update of the Cooling Environments Group from Open Compute Project 18 May. We're trying to do these on a quarterly basis. I'd like to open up with Michael Schill kind of giving a review of some progress, recent success at Open Compute Regional Summit. Michael, you want to give a quick discussion there?
Yeah, thanks, Don. Appreciate it, everyone. Hey, Michael. I'm sorry, everyone. My name is Michael. Sorry, it is a Thursday that feels like a Monday, as you can tell. Yeah, so the OCP Regional Summit was held a few weeks ago, April 17th through 19th, back in Prague, in the Czech Republic. It's our first time back in Europe since 2019, so we're really excited to be back. Some quick highlights here. Don, if you can go ahead and just advance your slide one. Perfect. We had roughly 600 attendees. I think we came in just shy of 600, which we're very excited about. Had over 100 different talks which were given, which you just put that in perspective. At the last Global Summit, I think we had about 340 talks. So we came in at 107 for a much smaller event. So lots of great content there. We have published a full recap blog, which you can find on the OCP website or in the link there in the slides. Encourage you to check that out. And then perhaps most importantly, most exciting, oh, thanks, Don. All the recordings and all these slides from every single talk that was given in Prague are now live as well. So that's something that we're really excited about. Please, if you find a talk that's interesting, or if you were a speaker and want to, boost your online presence a little bit, share that out, tag us. We'd love to retweet you or repost any of that and, get that out to a wider audience as well. I believe we have Kaylee Burdett on. Kaylee's OCP's Director of Global Events. Kaylee, is there anything that I missed in that quick regional recap there?
I just caught the very tail end of it, and the tail end sounded great. So I'm sure you did a great job.
Perfect.
Sorry.
Perfect. And then Kaylee's going to be on at the end of the call today. She can provide some information about the upcoming OCP Global Summit. So stay tuned for an update on that. Don, back to you.
Thanks for the introduction. Actually, one thing I was kind of amazed here is that's a lot of countries there. If you look at all the countries that are participating in that, and I kind of like to highlight that as we jump into today's discussion. Today we're looking, and what Michael was referring to was the OCP Regional Summit, which was all of Open Compute Project. Today we're focusing on the concept of "Don't Fear Liquid Cooling," which has been a tagline for and Plan for IT, or Plan for IT. This has been a tagline for cooling environments for the past 3 years, roughly, or the components of cooling environments. Today, what we're doing is going to give an update from each of the communities, each of the sub-projects associated with cooling environments. But fundamentally, I will also say the topic's become a lot more exciting lately. This AI is actually accelerating the interest and need for a standardized process for deployment at scale. And I'm going to hand off real quickly here to my co-lead, Sean Sivapalan, to walk through and just quickly map out what is Open Compute Project and why we are someone that's really helping change the world, and would love to have your participation or increased participation as well. Go ahead,
Thanks,
Sean.
Don. Thank you, Don. I think for those of you that don't know, I think most folks do know, we have a really wide ecosystem here at OCP. There's over 300 members from a wide range of the IT industry, whether it's cloud providers like Microsoft, Google, all the way through telco with T-Mobile and those sort of companies, including data center equipment, IT equipment, and then finally component providers like AMD and Intel. So as you can see, there's a wide ecosystem, and we do have this cross collaboration between the various members, which we think really does drive forward the innovation across OCP. Don, do you want to move to the next slide? Thanks. So there's a variety of projects and sub-projects within OCP, and what we're trying to always encourage, and we have been doing quite successfully recently, is the cross-pollination of ideas across sub-projects and projects between rack and power, cooling environment, sustainability. You'll see some nuanced ones like DC facility to cooling environment, hardware management and cooling environment, which you'll see from the immersion sub-project, and then also more recently cooling environment sustainability, which is one of the tenets of OCP, which we'll go into next. So the 5 tenets, core tenets of OCP are efficiency, scalability, openness, impact, and sustainability. And you'll see this in all the content that is contributed to OCP, and it's one of the 5 pillars that the reviewers and IC community look for when we're looking at content. So it's integral to how the OCP operates and how we ensure that we're making a real impact with the content we have within the community.
So this is where I jump in and again highlight that for a while the liquid to the rack community has been maybe what we call boutique. It's deployed at not necessarily at scale. What we're seeing in the past year is a urgent need for exactly what we're talking about here: these efficiency, scalability, openness, impact, and sustainability for cloud scale deployments. The future of our data center industry depends on our organization or our industry coordinating these areas, particularly around liquid cooling. And so this is a very timely and urgent discussion. Sean, you want to go and introduce the full team here?
Sure. So our incubation committee representative for cooling environments is Steve Mills. The project leads are myself and Don. Leading the door heat exchanger sub-project is John Fernandez. The cold plate is Jordan Johnson. The immersion is Rolf Brink and John Bean. The advanced cooling facility is John Manoche and John Gross. And finally, heat reuse is Cosimo and Jaime, who we have.
Okay.
Yep.
So today's discussion, we're going to be going through each one of the sub-projects, the advanced cooling facilities, often called ACF, heat reuse, door heat exchanger, cold plate, immersion, and we'll finish with a call to action. Maybe kind of explaining these a little bit. What we call door heat exchanger, cold plate, and immersion projects. Those are specifically looking at developing work streams to optimize those specific products or OEM solutions or solutions, if you will. Advanced cooling facilities, that group was brought on board to look at how to plug these all in. What are the concepts that are associated with piping that need to be standardized in order to achieve those goals of scalability, efficiency, and impact and sustainability, and open. And then heat reuse ended up being a project that we looked at. It's a potential benefit that becomes, number one, a sustainability issue and is growing in interest in sustainability. But number two, it becomes potentially more viable as we look at many of these cooling solutions. So opening with the sub-project, unfortunately, John Gross and John Manoche were not able to attend today. So what I'd like to do is real quickly run over some of what they have been doing and what they've done already. And I'm going to come back to this slide about what they have been doing and start real quick with what they have done or what our vision was. And the vision ends up being that we help projects be the ACS groups, the cold plate door heat exchangers and rear door and immersion, become solutions that can be added in what we call DFMA, Design for Manufacturing Assembly. The ability to add without impact on operating data centers. That was one of the key things that ACF was first started with, because as we all know, most of the data center industry currently is populated with air-cooled IT. So one of the key challenges ends up being, how can we add liquid in operating data centers? We can't throw away the existing legacy. We need to figure out how to keep going forward, and to a large extent, there will still be a large population of, and probably a dominant population of air-cooled IT going forth in the future. There will be some exceptions that people are looking at. And so what we looked at there was some came up with some facility water solution requirements. We're also looking at trying to standardize the TCS requirements. So when I say TCS requirements, we're partnering with ASHRAE TC 9.9. I'm going to go back up real quick to this slide here. One thing to highlight here is that John Bean and John Gross, both of those are editing members of ASHRAE. We partner with ASHRAE. We don't compete with ASHRAE. And so as you look at the stream, what we're looking at here, we've created some requirements. We've created some recommendations. The requirements are ones that are already, they should be achievable, and I think the industry is already aligning with. One unique aspect we're looking at is BIM content. BIM content is fundamental in terms of having vendors provide constructible grade BIM of their products. It will greatly accelerate the ability to do what you see here. The concept of being able to go to any of the vendors of the ACS product, download from them something that you can put into a construction document, and by that we're meaning not 25 megabytes, but 600K of product that or design that you can put into a design level solution and have it migrate to a constructible level solution. In the construction industry, we talk about level of definition and detail, and LOD levels of 350 is basically what we're looking at here. And we're continuing to refine. That's one of the work streams that we are actively looking at, is how to refine that to being something that the vendor industry can adopt. Many of the vendor industry do not understand the construction industry, and we need to help marry that. The areas of recommendations, OCP recommendations, we're not making those required, but the vision ends up being fundamentally your connection points need to be as interchangeable as possible as you go forward in the future. So by starting now, while the industry is still fairly young, and trying to make sure that where threads are used, we standardize on one thread. For reasons I'm not going to go into, we chose BSPP. And where interchangeable connections are used greater than 2 inches, or 2 inches and greater, we looked at both mission critical grade couplings, and we came up with a definition of what meets a non-leak requirement for a coupling. And we also looked at flanges, and those are both integrated into our design. One of the key aspects ends up being, in many situations, what we're looking at here is translating this BIM drawing into basically, in many cases, a coolant distribution unit, and also a distribution methodology, a standardized global distribution methodology that can be swapped in, swapped out. In many situations, when you get down to the levels that we're looking at here, flanges can become an impediment. Alignment and movement accommodation needs to be integrated. We talked about those. One thing we also looked at is the industry standardized right now, much of the chill water industry is defined around about a 8 degree centigrade, 14 or 13 or 14 degree Fahrenheit solution. And at that level, for data center owners, we said, okay, at those levels, a 3-inch pipe equals 300 kW of load. A 4-inch pipe equals 600 kW of load. A 6-inch pipe equals 1.2 megawatts. And those aspects ended up being something that is helping data center owners just kind of picture, okay, how big a pipe do I need to provision? How much space, how big a tap do I want to make sure is available? Most data center owners are not going to change their pipe solution for anything less than a megawatt. So a 6-inch pipe tap off in a existing design would be something you'd want to consider as a consideration. The other discussions we've had are on balancing valves and the branch line connections, in terms of what is the requirement to make swapping IT interchangeable as much as possible. There's still work to do. We also looked at the concept of, and we just gave a presentation last week at Data Center World AFCOM down in Austin. The discussion was how to do a cloud scale liquid-based 100% liquid to the rack, or liquid to the tank, or liquid to the door, or chip solution set. And so what you're seeing here is a picture of what we had, what was presented at ASHRAE from courtesy of Wyoming Hyperscale White Box, which is one of our members, as well as Burns and McDonald spoke, Sam Allen, who's again one of our members, and John Gross, who's one of our project leads. So going back to going back to where we started, things that we have, work streams that are going on right now. Concurrent maintainability. We are partnering with the Uptime Institute to help define what is concurrent maintainability in a data center. I already mentioned we're looking at BIM specifications. We're working with Autodesk to come up with a clearer definition for the vendor community so that they can provide constructible drawings to easily deploy, not only design and deliver, but plan for the MOPs, the methods of procedures, the operating procedures, and standard operating procedures. We're looking at a physical parameter survey of ACS to try to find a sweet spot of delta P, delta Ts, that we can actually help the community design around. We're not going to get 100% of the industry, but we need to get enough that people can start a basis of design, if you will. Coolant distribution units is an area that definitely is going to see some growth. As you deploy these solutions, if they're connecting to an existing facility water solution, you're going to want to have some sort of a barrier or coolant distribution unit, which is basically some combination of pipes and heat exchangers and pumps, and maintenance point for checking and updating your water solution. Co-location site assessment. One of the things we're looking at is trying to make it easier for colos to, on a global basis, share SLA and risk factor with their community. And then, as we're also going to do, and I'm going to lead into next, enabling heat reuse. We always, at advanced cooling facilities, are keeping in mind that in many situations, the heat exchanger we're going to may not just be going to atmosphere, it may go to a productive use. And with that, I'm going to actually transition to Jaime. And Jaime is going to talk to us a little about some of the stuff we're doing with heat reuse. Jaime, you there?
Yeah, I'm here. Thanks, Don. Thanks for a nice transition. So the subproject of heat reuse started more than 1 year ago, and it was started because I think you mentioned that, Don. We realized that there was a lot of attention around heat reuse. That it was getting it wasn't really a hype, but getting something really real, and we needed to do some work on that. So we have done so far we have realized different outcomes. So we started with the heat reuse guidelines. This was the idea behind that was to have an extensive document with helping and giving guidance to the different stakeholders involved in heat reuse. But we have stopped that work when we realized that we might develop something shorter, which is the Heat Reuse 101 article. It's a much shorter one. It's 5 pages. Is completed and already submitted, and only needs a couple of corrections before it goes out. So this one is more like for starters, for newbies in the heat reuse field, and we believe it can be good for creating more attention, for gathering more attention. Then we got the map, the heat reuse map, because after having a lot of guest presentations, which is, the last point is about the guest presentations, where we invite different people from the industry and from different sections of the industry, showing us their experience. We realized that there were many more projects as we thought. Yeah, as you see in the map, you have a lot of dots there. You can go one slide next, please. Then we come back afterwards. Done. Yeah, you see then you have the around 70 projects that we have listed so far. We have around 10 that we haven't put already in the map. Blue dots are projects that have been already done, then they are under operation, and red dots are projects that are being under construction or are just projected, planned. So if you know any project that is being planned with heat reuse, please let us know. We'll put it in this map. And next slide, please. The last feature we have in this map is when you click on one of those dots, you have a form, a Google form, where you can fill in with the details, the technical details of the project. of course, the technical details that has something to do with the heat reuse, like temperature levels, the power that is the installed power, and the power that is given for heat reuse, and what is the use case, and what is the distance from the distance from the data center to the off taker, to the heat off taker, and so on. We believe that this amount of details um, are quite important for the community to realize other use cases and potential projects in other places. Even if each project seems that is not really replicable everywhere, but it gives a lot of ideas and a lot of inspirations, and we believe this is positive. Can you come back to the first slide, please? Mm, Thank- but yeah, exactly. So, and about the guest presentations, I want to tell something. So we have had so far 18. Last one was past Tuesday. That was Qscale Canada, a colocation data center that show us the importance of considering heat reuse from the beginning of the project, before choosing a plot for developing a data center. So this was a very nice use case we had past Tuesday. The average attendance of those calls have been a bit decreased, unfortunately. So we are looking for a different format, maybe shorter presentations around specific topics, maybe 2 of them shorter during 1 hour, and maybe with another type of discussion. So we are thinking about it. So all your feedback is more than welcome, because at the end we're doing this for you all, for the community. And the last thing I want to comment is a checklist. And now, if you can step to the last, thanks. So the heat reuse checklist is the last thing we have started, and this is a we are in the first steps of this tool. This should be a tool that will be very useful for decision takers in DC development companies, for engineering consultants helping development of data center projects, or even retrofit, or even changes, modifications in existing data centers, or for anyone with interest, of course, around heat reuse. And what could bring this tool? This tool could help to assess the starting situation of a project. So where is there now? I mean, what needs to be done? Then offer a gap analysis from an ideal situation, yeah, for heat reuse, and even to give a score potentially. I mean, we have to still see this more in detail, to give a score for the feasibility of heat reuse. At the end, this kind of tool could show how far you are probably also to be heat reuse ready, or if you can have a nice project really around you and you're not seeing it. And this is it, pretty much. I mean, I think the last point was in the first slide, but no need to go back. Is about the matchmaking platform. The matchmaking platform would be a platform where data centers. Oh well, it's not there. That was is a new version that is not uploaded probably. So matchmaking platform would be the platform where the data centers with excess heat could meet potential heat off takers, and this is something is being developed in some places in the world. For instance, in Germany, there is an institution developing this. We would love also to contribute to make this possible, helping also to give some guidance there. So
Jaime, I want to thank you for this. I'd also tell you, to everyone on the call, heat reuse is an interesting aspect. There's people that looked at it in the past and they said we can't get there from here. But as the data center industry evolves, it is happening. And I've had, later on this week, I've got several investors calling me, want to understand how this can happen. The world of sustainability isn't an option anymore. It's not something you do because you want to be nice. More and more, we are doing it because it's going to be required. And we're also finding that once you open the door on doing it the second time, once you try something the first time, the next time it becomes economically advantageous. And one of the key aspects of that Wyoming Hyperscale White Box is an extensive analysis of the financial benefits of trying to look at heat generation as an asset, not just as a waste product. So thanks very much, Jaime. We'll go on next. I'm going to hand it off to the wonderful world of door heat exchangers.
Thanks, Don. I think I'm covering for John Fernandez from Meta. He leads the Door Heat Exchanger subproject. So the some of the current and upcoming community-led discussions that are going on in Door Heat Exchanger include megawatt deployment of IT racks with Door Heat Exchanger alongside the advanced cooling facilities that Don touched upon briefly. There's also a white paper on demystifying modular data centers with hybrid cooling with the MDC subproject and DCF MDC subproject, and I believe that's modular data center. And then Door Heat Exchanger is part of the facility interfacing with OpenRack v3, including integration and sourcing at scale. And then finally, a white paper comparing the Door Heat Exchanger coil types options, including aluminium versus copper tube fin and aluminium microchannel type heat exchangers. So heat exchanger coils. There's also another effort on hold currently with the circular economy and sustainability aspect of Door Heat Exchangers, where it's a collaboration with the sustainability and ACS cold plate subprojects. That is something that we discussed a little bit a couple of months back, and we hope to get going again. Thanks, Tom.
Okay, well, I appreciate that. I want to jump in here real quick, a couple other comments. The partnership between the Door Heat Exchangers and ACF is definitely an area of great opportunity. Door Heat Exchangers actually have been probably the most common liquid to the rack, if you will, measurement that people have been using for decades, although there are other methods taking it inside the chip. But coming up with a way to make it so you can transition Door Heat Exchangers which is a liquid to the rack solution, to liquid to the chip, is all about the pipe. If you can distribute, if you go to a data center that is using 100% Door Heat Exchangers, for example, that is a method to do air-cooled IT. And with the liquid distribution already in place, if we can standardize or come up with a sweet spot for delta P's, delta T's, and water conditions, then the concept of transitioning from a Door Heat Exchanger to Door Heat Exchanger plus a cold plate solution, or swapping out a Door Heat Exchanger with an immersion solution, is where we see the goal of the marketplace to be able to accommodate any of those three technologies. So it's kind of working together. And as I mentioned before, this is a great transition point to the cold plate group, because cold plate could be an independent solution, but it can also be something that partners with Door Heat Exchangers. But it definitely needs benefit of a global standardization. So without further discussion, here's Jordan.
Yeah, thanks, Don.
Hold on. Oh, there we go.
All right, yeah. So, I'll give just kind of maybe a brief overview of the ongoing work the community's doing. Like Don has mentioned some things on standardization, and then also, right, as this AI is getting big and more interested in liquid cooling, I'll just verbally talk to some kind of next steps or directions we could go with the community, with the expertise. But to start out, we've got a cold plates requirements work stream. So this is looking at to inform users and kind of point out things that need to be considered, what the different trade-offs, what the different options are. Some big additions in this second revision is looking at the trade-offs and some options around two-phase cold plate. And then we've also spun off a second kind of requirements document looking more at loop heat pipe type solutions. There's also and I guess one more thing on that, this is wrapping up and expected to be contributed and presented by the time of the Global Summit. And in our monthly calls, we're going to start reviewing that with the community, make sure we're really capturing really key parameters of interest. For the ORV3 blind mate interfaces, so this is a closed work stream led by Glenn Stress with Meta, but that is nearing a design guide. They've been going through multiple prototypes using this blind mate connectors for the ORV3 OCP racks, and so they'll also be presenting at the summit as well. And then currently in review, kind of in a similar vein as a specification that was published or is in review to be published, looking at large quick connectors. Sorry, yeah, and then like Sean said, yeah, we did actually kick off some work looking at sustainability a few months ago with the door heat exchanger sub project that has hit some snags and some people have moved around, but that's something that is really important moving forward. Like Don was saying, sustainability is not kind of a nice to have anymore. It's definitely a must have, need to have. And then moving forward, just talking with folks in the community, there's interest in, how can we give guidance on, for example, connectors within that cold plate loop? Can we standardize between cold plates? There's a lot of like community knowledge. There's entire companies that devote all their engineering to these connectors. Can we share that information with people that are going to be using these? What are the considerations they need to look at? And how can we inform on that? Can we take current connector specs that are at OCP, make sure that they're current, they're up to date, they're as good as they can be for the liquid cooling community. Another thing, we've started to talk about, and if anyone's interested in, kind of kicking these off, please just reach out to me. But we've also talked about looking at test methodology and standardization, right? As liquid cooling gets bigger, and you need to compare products or compare solutions. Can we standardize how things are tested, how they're validated, whether it's the CDU, cold plate, connectors, whatever that may be, so that if you're using liquid cooling, you have all that kind of information, apples to apples comparison. And then finally, I think looking forward, like Don was mentioning, what does cold plate look at large scale deployment? What kind of expertise can we get from you, from just the broader community to come together and put together some sort of guidance or information, and what would that look like for specific power levels for a data center? We did have some initial discussions with rear door heat exchanger on this, but looking to actually kick off maybe a more focused work stream in that area. I think that's all I got. Thanks, Don.
That's a lot, and actually, I'd like to kind of highlight a couple things real quick, and one of them is exactly what you finished off with. The industry right now, cold plate is not a new technology, but it's characterized to a large extent by a product. Someone modifies a server, and then they build a liquid distribution solution around that server, and that becomes a standardized product. As we look at a global, if we start deploying, current deployments are somewhere a couple hundred kW or to maybe 1 to 2 megawatts. As you start looking at the potential for 30 megawatt solutions, which is a very viable solution, the industry it needs to have an interchangeability, the ability to go from one product to another product to swap out. The large cloud scale hosts are not going to want to depend on one vendor, and that's where OCP got its start. OCP got its start when you started looking at air-cooled IT back in 2011. We need to do the same thing with chip-cooled IT or liquid-to-the-chip IT, and make it so that there is some accommodation so that we can get multi-vendor solutions on a global basis, because supply cannot be supported by any one vendor globally. As much as it may sound exciting, nobody has that capacity, resource, or global support. So that's where OCP is fundamentally, this is one of the most important projects we have right now, because cold plate has some key physics advantages for some of the solutions. Another unique and great solution, our final of the 5 sub-project review.
Real quick, Don. Never mind.
Yeah.
No, go ahead. Looks like they're not in there.
Yeah.
That's good. Never mind. Sorry. A little hiccup there.
But so now we, with a drum roll, we go to the immersion project, and I'm going to introduce Rolf. Do you need a drum there, Rolf? Or are you pretty good?
Yeah, sure. Go ahead. I'd love to get a drum. if you have one. No, thanks. Let's kick off with the first slide straight away. My name is Rolf Brink. I'm the project lead for the immersion community. I'm co-leading together with John Bean from GSC, and I'm from Promersion. And I'm just going to very quickly highlight the types of immersion technology which we're dealing with, because hey, this is a domain with quite a bit of variations. Basically, there's a difference between liquid cooling and immersion cooling, obviously, but I'll go into that. Liquid cooling is the principle of extracting heat from components without air as a medium, whereas immersion cooling goes into the full submersion of IT equipment in the dielectric liquid. And a dielectric liquid being a fluid that is non-conductive, so insulating properties, but it does conduct heat. And the liquid therefore directly absorbs the heat from all the electronics components, not just the main hot chips. Within the domain, we have a main division between single phase and two phase fluids, and the basic difference is that we're dealing with a different type of displacement of heat. Single phase consists of low volatile fluids with a very high evaporation point and therefore a high stability, and the fluid is normally circulated through a heat exchanger to facilitate the heat rejection. And this can be done by mechanical means with pumps or by natural convection flow. With two-phase fluids, we're dealing with the phase change properties of material. So the fluids that are used are usually high volatile fluids, and the volatility refers to the fact that it boils at very low temperatures. And it's the boiling itself which is applying the cooling effect. So by boiling the fluid, you're triggering a phase change of the fluid into gas, hence the two-phase reference to it. And that phase change is powered by the heat source. And therefore, it's a very efficient means of rejecting heat, especially when you have fluids that boil at lower temperatures. And the circulation then is achieved by condensers above the fluid surface. Now, next slide, please. Yeah. So we're not only dealing with single phase or two phase, but there's also some different implementation types. So we have open bath systems, and this is what people commonly refer to when they are talking about immersion. And these are tank style systems. And the term open bath, especially the word open, doesn't refer to a lid, but it refers to an air interface that sits on there is a layer of air above the fluid surface. So there is an open to air interface. But both single and dual phase technologies can be an open bath style. However, open bath is not the only implementation type of immersion. We're also dealing with enclosed chassis, which from a facility point of view, you can almost consider that similar to cold plate environments, where you have fluid connectors on the chassis, also referred to as clamshell designs. And the main difference is that these are usually inserted into vertical racks, which resemble the more traditional air cooling equipment. We do take into account some hybrids where open bath tanks can be inserted in racks or can be dealt with in other form factors. Right now, we don't have any of those technologies that we are aware of within the community, but there is a good representation of open bath and enclosed chassis, single phase and two phase technologies within the open compute community. Please go ahead, next slide. So having said that, so I've just explained the domain, and but despite all the attention to immersion cooling around the whole world, it still is a disruptive innovation. And that's due to the fundamentally different form factors, the different ways of work, and the extreme efficiency gains compared to other technologies. The data center operators, they do prioritize availability and uptime, and therefore are naturally cautious about adopting new technologies. And any doubts raised in the industry don't only affect a single brand, but the entire technology domain. And overcoming the stigma associated with new innovations is something that requires a lot of time and a whole lot of factual evidence. And this is a pretty big deal. This is also difficult to overcome. Industry-wide collection of data and sharing of that data is very often at odds with confidentiality. This is not a challenge that is unique to immersion, uh, but in this case, but it's a little bit more present in the immersion domain, mainly because it's driven by forward-thinking innovators, which must strike a delicate balance between protecting the intellectual property and supporting the growth of their own new technologies. After all, a technology needs to scale for itself, but it cannot do so if you can't share information. And one way to deal with that is something that we've been doing in OCP, especially in the immersion community, but also in the other cooling environments community. Open the floodgates and create the rising tides that lift all boats. We are aiming to provide the industry with unbiased facts, and we make sure to include the data to back it up. And this is all because the progress in OCP is driven by a community. This driving force is coming from the innovators, hyperscale companies, and therefore we're usually more progressive than other industry platforms. And this has resulted in one of the biggest projects within Open Compute. Next slide, please. And this is what this project looked like. And this is not the final stage. It's going to expand further this year. The immersion project is led by John Bean and myself. As mentioned before, we maintain relations directly with ASHRAE and IEC. IEC is the international standardization body, and that's very relevant because one of the main challenges for immersion is the fact that there are no industry standards for immersion yet, and that's something that we are actively pursuing and generating and facilitating with the broader community. But OCP is not a standardization body, but IEC is, and we have various work streams within the OCP project, which are all aimed at resolving very specific hurdles related to immersion. One of the notable ones is the Immersion Hurdles project, which I'll get into in the next slide. But we have a work stream for hardware management for liquid cooling, which is actually a cooling environment broader work stream. It's a cross-project collaboration where we're creating a unified schema for data center infrastructure management purposes that can facilitate cold plate or heat exchanger and all the variations of immersion technologies. We have a material compatibility workstream, and I now realize that this image is outdated because we've renamed that to fluids and materials. And it's led by Punit Shiva-Prasad from Shell and Peter Cooper from Submer, whereas hardware management is led by Mick Jones from Vertiv. Immersion requirements is a workstream that is similar to the cold plate requirements, but in this case focused on immersion domain, and that is led by a new workstream lead, Rick Margarison, and myself. We have a project that's focused on the power distribution, specifically into immersion environments, which is more challenging than vertical racks or has different challenges. It's led by Harry Soin from AEI and Oriol Chavanel from Submer. OEI collaboration is something that we're doing together. It's a collaboration with another OCP project. It's a sub-project to the server group, to the server community, Open Accelerator Infrastructure. This is where the future chips are being developed in a closed group. These are GPU style chips. They're already looking into 1 kilowatt, 1.5 kilowatt chips. So 1,000 to 1,500 watts, which is of course incredibly challenging from a cooling perspective, and therefore compatibility with all the cooling technologies is incredibly important. So we are collaborating with that community to facilitate knowledge transfer and to facilitate the partnerships that can make sure that the chip development will become compatible with all these cooling technologies. Then we have a work stream focused on TCO modeling. One of the big challenges in the industry is that for a lot of people, it can be very challenging to create a business case around, hey, so how do I build a total cost of ownership model when I'm looking at immersion versus air cooling? One of the key conflicts that you very often see is that people assess the cost of a tank and compare that with the cost of just a metal framework, which you're used to as being a rack, which is not a fair comparison, simply because immersion does a lot more than just hold some service. It is an entire cooling train that is embedded within your white space. And therefore, providing clarity on, hey, what are the TCO effects of dealing with immersion is critical, and this is something that we're working on within this workstream. There is a workstream now focused on the warranty guidelines. One of the hurdles for the industry is still the fact that IT equipment very often loses warranty as soon as it's immersed. That's something that we need to resolve. We're doing that together with the equipment manufacturers, and this workstream is led by Rich Lappenbush from Supermicro and Michael Cordell from Seagate. And then last but not least, we have the signal integrity workstream, which is looking at the signal integrity effects. This is a fairly complicated topic, which has recently been extremely well explained by Andy Young from Asperitas, who did a fantastic presentation at the regional summit recently, and there's a recording of that presentation as well, which is the basically the beginner's guide to, hey, what does signal integrity mean, and how serious do we need to take this, and how can any challenges be resolved? And it provides a very good overview. And that community is led by Kai Wang from Intel and Andy Young from Asperitas. Next slide, please. Because I did promise to get into the immersion hurdles. Hurdles is a strategic workstream within the immersion community. I think personally it's probably the most important one that we have. The immersion hurdles workstream is tasked with the identification of anything that is in the way of immersion. So that workstream is actively looking for reasons not to adopt immersion cooling, and tries to find the collateral and identify the real underlying issue for not wanting to support immersion. And it identifies the required efforts to resolve that issue. And that usually turns into the creation of new workstreams. So basically, the hurdles workstream is the incubator of new workstreams. So what happens when a hurdle has been identified, the basic material has been collected, a new workstream is being created, where we create a proposal, we do a call for leadership, and we create a call schedule, and we invite leadership to run with the specific hurdle. And that hurdle will then be actively addressed by a new workstream with its own community, consisting of specialists or specific people who are geared, who are equipped to deal with the specific challenge. A few examples, if we can just go back one slide again to show the org chart again, Don. So good examples of this recently kicked off work streams are the TCO modeling, warranty guidelines, and signal integrity. They have been created in December. We found the leadership and assigned the leadership in January, and the first project calls were kicked off in February. And at the recent summit, I was incredibly impressed to see the depth of materials that have already been collected and the work that has already been done. I do expect a few more work streams to be kicked off in the next half year. The hurdles team is now also looking at very specific hurdles, and you will definitely hear more about those as soon as we do kick them off. If you can forward 2 slides, because I'm going to be working towards the roundup. Any information you would like to have about the immersion project can be found on the wiki. The QR code is in the bottom right corner. Feel free to scan it. It should bring you directly to the wiki page, which contains a full overview of all the contributions that have been passed. It gives you an indication of the immersion requirements qualification process, and the checklist. It also gives you the full overview of projects and work streams that we're dealing with, and it also gives you access to all the calls and presentation materials that are used in the main project call. Next slide, please. Our call schedule is weekly, usually divided over the Mondays to Wednesdays. We have always between 7 and 9 a.m. Pacific time. That's when we have all the different workstream calls, and that schedule can be found on the wiki page as well. Next slide, and I think that's the last one. And here are a couple of examples of recent material publications. Most of these came out in December. Actually, all of these came out in December. It contains the material compatibility information, which is a fantastic document containing all the testing results of the various fluid manufacturers of different materials. There's a base specification for immersion fluids by Intel, which is now going to be used by most of the large enterprises as reference material for providing warranty or for supporting immersion cooling. And there's a fantastic white paper by Microsoft focused on warm liquid cooled cloud facilities. So with that, I am concluding this session. Glad to be handing back over to Don.
Well, thank you, Rolf. Just kind of going here. Get that screen to move. Oh, go back here. Real quick, we have some upcoming industry participation there's an OCP Global Summit and coming up this fall, which was well attended last year, and also we'll be speaking and hosting a workshop in. Michael Schill, do you want to talk real quickly to these?
Yeah, we actually got Kaylee Burdett on. Kaylee, if you want to speak very quickly regarding the OCP Global Summit, we'll maybe try and do a quick little speed run here so we still save Steve a few minutes at the end.
Yeah, sure. I'll be quick. Hey guys, Kaylee Burdett here, Director of Global Events. Michael is showing you the Global Summit website, so please join us in San Jose at the Convention Center October 17th through 19th. Again, it'll be 3 days like it was last year. Our theme is scaling innovation through collaboration, and Cliff Grossner just wrote a great blog on why we chose that theme, so you can check that out on the homepage. There's a link to that blog. Right now, sponsorship sales are open. All booth levels are available, and some of the event sponsorships are still available. At the top, there's a sponsor tab. Oh, I think he's already on it. Yep. If you scroll down, Michael, you can see which event sponsorships are sold out. It's first come, first serve. So please contact me if you're interested. We will begin booth selection in just a couple weeks. And then if you go to the call for presentations tab, we have submission periods open for a variety of things. We have the engineering workshops and special focus tracks are open, and also papers and technology demonstrations for the Future Technology Symposium. Submissions are open for that. And then finally, we have submissions open for Experience Center stations. That page isn't updated yet. I'm going to put a table at the very top which outlines all of these so you can see it in one quick spot. So sorry about that, it's not updated yet. But Experience Center stations, we are taking submissions for that as well. And you can see all the details there where Michael is on. And then registration will be opening in June, and the pricing will be the same as last year. So just make sure you register before July 31st to get the early bird rate. And I think that's about it. Michael, did I miss anything?
The only thing I was going to mention, there's some upcoming OCP events. OCP will have a presence at DCD Connect Silicon Valley coming up June 24th to the 26th. I think that was what Don was showing there. I believe, Don, you might be speaking there as well on our behalf.
Panel, yeah. I'll be on a panel discussion, also participating in the workshop development. So yes.
Which is great. And then if anyone is interested in the NIC Mezcard space, I will be attending the Smart NIC Summit in just a few weeks in San Jose. So reach out to me if you're interested in a potential pass, or we are still looking for some folks for some speaking opportunities there.
I acknowledge there's not a ton of overlap between the knit card space and cooling environments, but wanted just to plug that really quickly.
Okay, and finally, I'd like to have Steve Helvey give a quick update on OCP Marketplace.
Hey, Don, thanks. I'm going to quickly share my screen here, everyone. Great. Don, is that showing up okay?
Yep.
I see it.
Great. All right. So for those of you on the call that may not be familiar, the OCP Marketplace is our route to market. So we have, once something comes into the contribution side, the marketplace allows those members to then showcase their products or solution on the marketplace. We have redesigned the marketplace as of October. There are now 4 separate sections showing integrated solutions and the corresponding categories. I just wanted to share some numbers. Through Q1, the marketplace receives around 9% of the total views of the marketplace. So that's drilling into more detail. In the upper left-hand side, you see the 4 different sections of the marketplace. Products accounting for 60% of the total views per month. We are seeing an increase quarter over quarter. Let's see if that holds over the summer months. But on the right-hand side, you see the top countries visiting the OCP Marketplace. So there's many countries that we do not have localized content, but we still see a great number of views. When it comes to the top 20, I just wanted to highlight a couple areas. You can see the legend on the right corresponding to whether or not it's a product or a telecom edge or integrated solution. Approximately 30 to 40% of the top 20 have to deal with edge or telecom type of equipment. This is good for the cooling environment side. We only have really one current cooling environments solution, and it is in the top 4 worldwide of over 200 listings viewed. So I think there's a lot of upside for those members that are on the call that may have a product or a solution that meets a current specification or a current set of guidelines that have been produced, where we can list that on the marketplace. You can see a couple of heat reuse solutions as well. If you're on the integrated solutions piece, you can sort by workload. And if that workload is currently not on there, we can certainly add the corresponding workload. So we're expecting some more components as well as perhaps some connectors and things like that coming out of this group. We also have a set of experience centers. So if a member out there has a way to showcase some cooling environments with OCP solutions, that is something we can certainly qualify and highlight as well through our OCP Experience Center program. I did a session last Global Summit on how to go to market, which covers more details around our channel program and some of the things that we've been doing with other members. We currently have over 40 members in the reseller program or solution provider program. You just need to sign a couple of agreements. We can discuss what products or solutions meet a current spec or guideline. And then there's an annual fee of $4,000, regardless of the membership tier, for unlimited SKUs. And reach out to me for any questions, or have your product marketing folks get in touch, and happy to walk them through to make sure the members are getting the most value out of your OCP affiliation. And that's it, Don.
Hey, I really appreciate that share. As the kind of a summary of what we're talking about today, that's no surprise, and it's a very common statement that for years we've been talking about liquid cooling, but for months it's all of a sudden escalating. And this AI is not going down, it's actually driving new requirements. I talked to a data center owner this past week who mentioned that she's seeing 400 megawatts of new demand this past month. So in essence, in the past month, 400 megawatts of liquid cooled ITE popped up on her, we got to build this. So tying back in, people are going to need to have products to meet this need. It is escalating. We will be resharing this. I put the final screen that you should be seeing here are links to these projects. These are opportunities for people to participate in changing the data center industry for better, to align with a change that I don't think we've ever seen, the level of change in data center design that's going to be happening in the next couple months. And OCP is a fundamental organization to help making that happen. So we look out for participation. That's all we have today. I'm going to stop the recording and open for any kind of discussions. Hold on here.